Okay, another algebraic method for solving a nonlinear system is a process called elimination. In previous books, you may have also seen this as the addition or subtraction method. So when both equations of a system have second degree terms with like variables, it's generally easier to use the elimination method over the substitution method. So here we have a system of equations. And again, let's identify what we have. The first one is a circle. The second one is a hyperbola. And that you can see that each of these have second degree terms and like variables. Here's an x squared and an x squared, a y squared and a y squared. So elimination would be a good method for solving this one. So let's rewrite the second equation to line up all the variables. So again, let's write our first equation. And then our second equation, we're going to put the negative 2x squared first to line it up with the x squared with the first equation. Plus y squared is equal to negative 7. And what we're going to do for this one is we're going to eliminate the y's by subtracting the second equation. If you want to, you can multiply through by negative 1 and then add. That's perfectly fine also. And then you just add in column form. So we have 3x squared. Again, the y's are eliminated, which is what we want. And that equals a positive 27. Now we have one new equation with one variable. Divide both sides by 3, square root, and we end up with x being plus or minus 3. So we found our x's. Let's go back to one of our original equations and substitute in x as 3. So I'm going to use the first equation. And you see we get 3 squared plus y squared is equal to 20. Simplify and we get y to be plus or minus the square root of 11. So this is going to give us two answers, two solutions. So we have 3 radical 11 and 3 negative radical 11. Then we need to go back through and substitute in x as negative 3. Again, simplify, and we end up with, again, plus or minus the square root of 11. So now we have two additional points, negative 3 positive square root of 11 and negative 3 negative square root of 11. So we end up with 4 solutions in this case. And over here is just a quick sketch. Here's my circle. Doesn't really look like a circle. And then this is my hyperbola, and you see where those 4 intersection points are. So this is the elimination method.